Hello, and welcome to part 1 of my RPG Blueprint tutorial series. In this series, I'll show you how to create and fit together multiple systems that RPGs usually have, all in blueprints. In this first part, I'll be showing you how to set up a camera system and how to add some polish to it. I'm in UE 4.14, and I've created a project using the third-person template. I want to be able to have 3 camera modes: free look, over the shoulder, and first person. Let's begin. One of the first things we'll need are action inputs. So I'm going to go to project settings, going to go to input, and I've already added in a camera switch input, which I've used tab for, and a draw or sheath weapon input, which I'm using R for. I'm also going to need an enumerator that determines what camera state we're going to be in. I've already created it here in the content browser, and I've named it State Camera. As you can see, I have 3 enumerators: one for free look, one for left shoulder, and one for right shoulder. So now we're going to go to our third-person character, and we need to add a few things. First thing, we want to add in that camera state variable, and that will be used to determine what state we're in currently. And I've already changed the variable type to be correct. We also want to duplicate that and have another variable called last shoulder. This determines what shoulder we last used, so that when we go back into over the shoulder mode, we go to the last one we switched to. We also have a variable for is our weapon drawn. If our weapon is not drawn, then we don't want to be over the shoulder, so we'll use it for that purpose. We also have another boolean called is third person, and this is how we determine whether or not we want to be using the first-person camera or the third-person camera. Speaking of the first-person camera, we want to go ahead and add one in. So let's go to the viewport. I've raised up my camera boom to be at shoulder level since we're going to be usually being over the shoulder. I'm also going to add another camera component and name it camera FP. I'm going to attach it to the character mesh. This is going to be a true first-person camera, so I'm going to attach it to the head socket here. As there is an offset, I need to reset that so that it's directly on the joint. I'm going to rotate it to be right side up, and I'm going to move it forward. Compile and save. I like to have a wide field of view, so I'm going to set this to 110. And you need to have it use the pawn control rotation. Now we're ready to code. I'm going to add in a function called camera change, and this will allow us to switch between the first person and the third person camera. So I'm going to create a new function and call it camera change. We'll need an input determining whether or not we're going to be in third person. I'm going to create input and call it third person. I'm going to give it a question mark. Or rather, we'll match it to the variable we've already created and call it is third person. Compile and save. And from this, we can determine which camera we want to be active. By default, the camera FP should not auto-activate, so it should never be active in the beginning of the game. However, if we're not in third person mode, then we want to activate that camera and deactivate the third person camera. And we can do this with fairly little logic. First, we're going to get a reference to both our first person camera and our third person camera. From there, we drag out and get set active. And use it for both references. Drag it directly from the input. Make sure everything's linked up. Now, whatever state one camera is, the other camera should be the opposite. So we can use the same input and invert it for the other. So we're going to grab our variable is third person, and we're going to get a selector node with it. I like to use selectors a lot. We're going to select a return value based on our is third person input. And we'll use this for the camera first person. And again, we want it to be the opposite for the other camera. So we're going to get a not and plug that into the other camera. Now, if we are third person, then we don't want to use our first person camera, so true should be left blank. And the opposite should be true if we're not third person, because we do want to use the camera. So now this is set up here. We also want to change a variable called use controller rotation yaw. We're going to set that. What this does is it rotates the character in the direction that you're looking. We want this to happen when we're in first person, but we don't want this to happen when we're in third person. Or rather, we don't want it to happen in free look. So then compile and save. Let's go back to our event graph. I haven't set up an action input for switching the camera. I'm simply going to use the V key. Going to set a variable is third person to be the opposite of what it currently is. So we're going to set it by getting it and then plug it into a not node. And this will give us the opposite of what we are. Then we want to get our camera change function and plug our third person variable into the third person input. Compile and save, and we can go ahead and test it. As you can see, I'm in free look. My character doesn't move when I look around. If I press V, you can see now I'm in first person mode. And my character rotates when I rotate. I did notice I have to press V twice, and that's because is third person was not checked. We are by default in third person, so that should be checked by default. So now, the first time I press V, I'm in first person. And I press it again, I'm back in third person. So I'm going to put a comment around that. Call this camera view switch. FP/TP. The next thing we want to do is start our camera switching behavior with our input action for drawing and sheathing our weapon. I'm going to right click and get that input, draw and sheath weapon. From here we're going to set whether or not our weapon is drawn. So we're going to set And just like with the third person, we're going to set it to be the opposite of what it is. Is weapon drawn, and plug it into a not. If our weapon is not drawn, then we can rotate our camera freely. So we can do a check with a branch. Again, if that runs false, then we want to be in free look. So we're going to take our camera state and set it, and by default it's free look. Now if we're looking freely, then we don't want to use the controller rotation yaw. We want that to be false, because we don't want the character to rotate when we look around. That's why it's free look. If our weapon is drawn, then we want to go into the over-the-shoulder view. And if we had a preference for it, then we needed to use the last shoulder used. By default, this defaults to free look, so I want it to be the right shoulder by default. We're going to set our current camera state to be whatever shoulder we had last. So if our weapon is drawn, then we're going to use the last shoulder that we used. Now we want to be able to determine which shoulder to use. So I'm going to drag some of this down, and we need to get our camera switch input. So I'm going to right click and get camera switch action event. Now we only want to be able to switch our shoulders if we are over the shoulder. If we're in free look or first person, then we don't want to be able to switch shoulders. So we need to perform a check to see if we're not in free look. Do a check with a branch. And get our current camera state. And we don't want it to be free look. It has to be over the shoulder. So if it's not in free look, then we can switch shoulders. We switch shoulders by using a flip-flop node. This allows us to switch back and forth between two inputs by only pressing one button. So with our A execution, we're going to check to see if our current camera is on the left shoulder. Perform a check. Neaten some of this up. If our camera is on left shoulder, then we don't need to do anything. But if it's not on the left shoulder, then we need to make sure that it is currently the left shoulder. So we're going to drag that, set it, and set it to be left shoulder if we are not on the left shoulder. It's kind of backwards, but this is the logic that I typically use. And once we set it to the left shoulder, we want to show that that was our last preference. So we're going to plug in camera state into last shoulder. So the next time we need to use the shoulder coming from the free look, we now have an accurate representation of what we had previously. I'm going to duplicate this logic for the right shoulder. So I'm going to just kind of copy that and change these to right shoulder. And now we've set it up to where we can change shoulders. Now if we have over the shoulder view, we do want to use the use control rotation yaw, because we want to rotate our character in the direction that we're looking. We want to do that whether we're switching shoulders or if we're switching to the shoulders. I'm going to use a reroute node here to make this look a little bit neater. Let's see, that'll do it. So now we've determined what state we're going to be in, and we've set our controller rotation behavior accordingly. Now the way that we're going to use the camera system and move it around is going to be timeline driven. So I'm going to right click and add a timeline. Going to call it move camera. Bring that up here. Plug this in to play from start. We want to play this timeline from the beginning. And plug this in as well. So anything we've done with our cameras all ends up moving the camera. So I want to open this up, add a new float track, and call it alpha. The reason I'm calling it alpha is because we're going to use it in an interpolation, and that will require an alpha. Shift click to add one point on the timeline, and then another. The first one will be at time 0 with a value of 0. The second one will be at a time of 0.7 seconds with a value of 1. Now, this second node here determines how long it takes for the camera to transition from either the shoulder to the other shoulder or to the free look. So you can make this longer or shorter depending on what you want. But I'm going to click on both of these nodes and auto curve them. And we want to make sure that we're using the last keyframe. I could make the length 0.7, but if you want to fool around with changing how long it takes to transition, then you want to use the last keyframe, which I've set at 0.7. Compile and save, and that's it for the timeline. But we want to modify some behavior based on that timeline. So as we're updating, we want to change the socket offset for the camera boom. So that's what determines what shoulder the camera is positioned at. I'm going to drag out the camera boom and set the socket offset. I'm going to plug that into update. So every frame that this timeline is driving will update the socket offset. So for the vector, I'm going to make one. And we only want to change the Y value. And the Y value is going to be determined by an F interp ease in and out. So if you just type that in, F interp, and you'll see ease in out. This takes that alpha that we've set up in the camera timeline and transitions from an A float to a B float. So it's a very smooth tracking sensation. This exponent determines how the curve will work. So if the higher this curve, the slower, the more ease there is at the beginning and the end of that interpolation. So if it's higher, then it'll take longer to start moving and to stop moving. If it's lower, then it's a pretty straightforward transition. I'm going to put it at 0.5. So A is going to be our current socket offset, and B is the socket offset we want to interpolate to. So if we duplicate the camera boom here and get socket offset, we can actually split the structure pen and get each float out of it. So we can get the Y value and set that as A. The B value we want to select based off of what our current camera state is, because each camera state has a different offset. So we're going to get our camera state currently, and we're going to make a selection based off of that. I'm going to plug that into the B value. Now you can tweak these around. Free look is going to be 0. It has a 0 offset. The left shoulder excuse me, will have a negative 50 value. And the right shoulder will have a positive 50 value. And that's comfortable for me as far as being over the shoulder. So now we've been able to interpolate our camera offset. I'd also like to determine the camera boom length. I'd like it to be closer when you're over the shoulder and further away when you're looking around freely. So I'm going to get the camera boom and set the target arm length. And we're going to do pretty much the same thing as we did with the socket offset. I'm going to plug that in. And we want to use another f-interp ease in out. As far as the value of A, we want to use the current target arm length. So we're going to get target arm length. That's where we are now. And going to interpolate to our goal. We're going to use another select based off of camera state. So I can copy that, wrong one, and plug that into B. These values, free look starts off at 300, that's the default. And then over the left shoulder, I'd like it to be half that, as well as the right shoulder. Alpha, just grab from the timeline. And I'd like to have more of a curve when zooming in and out, so I'd like to have the exponent be 2. I think this looks pretty good, and you'll see in just a minute what it looks like. So now we've interpolated the arm length. I'd like to interpolate one more thing, which is going to be the field of view. I'm going to grab the follow camera, going to set field of view. And as you can probably guess, it's going to be very similar. I'm going to grab the f-interp ease in out. Going to get the current field of view. For A. And B, we're going to select based on the camera state. For free look, I'd like a solid 90. You can make this whatever you want. When we get into custom settings, we can have this be read from a settings file or a settings save. But for now, I'm going to use 90 for free look and have the field of view smaller and zoomed in for over the shoulder at 60. And the exponent, I'm going to use 0.5 and then drag the alpha from our timeline. Compile and save. And this should be good to go. I'm going to put a comment around this and call it camera switching states. Compile and save, and let's go ahead and test it all out. I got my first person, third person. So now if I press R, it should go in over the shoulder. You see how it zoomed in, tracked very smoothly. If I press it again, I smoothly track out. You can see that my character is rotating where I'm looking, and now it's not. I zoom back in, and now I press the camera switch button with tab. I've transitioned over to the left shoulder. If I zoom out and zoom back in, I'm back in the left shoulder because we've recorded our left shoulder. Switch it back to the right shoulder, zoom out, zoom back in, we're back on the right. I'm on the right, zoom out, and I'm pressing tab now. I'm still on the right. Just pressing it. So we'll only change cameras depending, it will only change the shoulder if you're already zoomed in over the shoulder. And as I'm sure you've gathered, it'll be over the shoulder when you draw your weapon, making it easier to rotate your character in the direction you need to attack. But there you have it. And that concludes the first tutorial on how to set up a camera system and add some polish to it. The timeline-driven changes makes it really nice. Gives it a nice smooth feeling. Next time we're going to be working on a little bit of the movement system, being able to sprint and crouch. And we'll show some logic on how to expand that to different movement features such as swimming or climbing ledges. I won't be going into those likely, but if you can do those on your own, you can switch to those very easily. Thanks for watching. If this video helped you out, you should like and subscribe. And you should follow me on social media as well. You see some behind the scenes on some of my other projects and be notified when I'm putting up another tutorial. That's it for today. Thanks.